Hey guys, Mrs. Flanagan here. Today we are going to review factoring. I've said it lots of times, factoring is huge, so important. You are going to use it every single year in your future math classes. And when thinking about factoring, remember the very first thing you should check is if there's a GCF. If there is a GCF, then you're going to factor out that GCF and write it in front of the parentheses. So whatever the GCF goes in front of the parentheses. And then what you put inside of the parentheses is what is left after you divide out that GCF. If there's not a GCF, then you just go straight to determining if there's 2 terms, 3 terms, or 4 terms. But if there is a GCF, you look at what's inside of the parentheses to determine if there's 2 terms, 3 terms, or 4 terms left in the parentheses. And so then remember that if there are 2 terms and the highest power is 2, then we use difference of squares. We check to see if we can use difference of squares. That's when both of our terms can be square rooted nicely. And this first example, we will use the difference of squares. So first, check to see if there's a GCF. Is there a number that both 25 and 36 can be divided by? No, there is not. So now we see that there are 2 terms. We look at our first term, which is the 25x squared. And can that be square rooted nicely? So when we square root that, does that give us a nice answer? Yeah, because the square root of 25 is 5, and the square root of x squared is x. So that can be square rooted nicely. And now we look at our second term, which is the 36, and we ignore the subtract sign. We're looking at just the positive versions of our terms. And is 36, can that be square rooted nicely? Yeah, that can also be square rooted nicely. It's 6. So because they can be square rooted nicely, we're going to put our 5x and our 6 in the parentheses. So put the 5x and the 6 in the parentheses. But what is a minus and what is a plus? It doesn't matter if you put the subtract first or the plus first, both are correct answers. Our next example, is there a number GCF? So a number that both the 1 and the negative 2 can be divided by? No, there is not. So there's not a number GCF. But remember, there can also be a variable GCF. A variable GCF is when we look at the letters. So is there a variable that both the x squared and the negative 2x can be divided by? There is, yes. So that means there's a variable GCF, and the letter that we can divide both x squared and negative 2x by is an x. So our GCF in this case is x. We write x out in front of parentheses. We show the dividing out of the x, and x squared divided by x is x, and then show the dividing out of the x. Negative 2x divided by x is negative 2. And now we look inside of the parentheses and notice that your highest power inside of the parentheses is 1. The factoring only happens, right, if your highest power is 2. So because our highest power is 1, we are done factoring, which means the final answer when we ask to factor this is x multiplied by x minus 2. For our next example, is there a number that we can divide 2, 6, 5, and 15 by? No. Do they all have A's? No. Do they all have B's? No. Do they all have X's? No. Do they all have Y's? No. So there is no GCF in this case. And now we come here and we ask, all right, well, how many terms are there? Are there 2 terms, 3 terms, or 4 terms? And there are 1, 2, 3, 4 terms. So back up here with 4 terms, it doesn't matter what our highest power is. We are going to factor by grouping. Remember that with factor by grouping, you group the first 2 terms, then you factor out the GCF from the first 2 terms. You group the last 2 terms, and you factor out the GCF from the last 2 terms. And then there should be matching parentheses, and you factor out that matching parentheses. So let's do factor by grouping. Let's group these first 2 terms together and factor out the GCF. Our GCF is a 2 and an A. Don't forget to check your letters for the GCF. So we write our GCF in front of parentheses, show that we're dividing out our GCF of 2A. 2AX divided by 2A means there's an X left over. Show the dividing of 2A. 6AY divided by 2A is a positive 3Y. And now let's group the last 2 terms together. And the GCF in this case is, we're going to use a negative because our leading coefficient is a negative. And then we have a 5 for that GCF, and the letter is B. So negative 5B is our GCF for the last 2 terms. We write the GCF in front of parentheses, show that we're dividing out our GCF of negative 5b. When we divide negative 5bx by negative 5b, we're left with a positive x. And then when we divide negative 15by by negative 5b, we are left with a positive 3y. Notice that we have matching parentheses. So that is our new GCF, right? We're going to factor out that x plus 3y. That's our new GCF. So we write our new GCF in front of parentheses, and then we write what's left after we divide out our GCF of x plus 3y. Those undo each other, leaving us with the 2a, and then divide out the x plus 3y. Those undo each other, leaving us with the negative 5b. And that is our final answer. For our last example on this page, let's see if there's a GCF. Is there a number that we can divide 1, 8, and 12 by? No. What about letters? They all have N's? No. So there's no GCF. Now let's look at how many terms there are. There's 1, 2, 3 terms. So 3 terms. Oh, and our highest power is 2. Make sure we check that. Yep, the highest power is 2. So that's when we do our number game. Remember, the number game is when we find 2 numbers that multiply to A times C, but those same 2 numbers have to add to B. Then we do our double axe hippo butts, and then we simplify inside each of those parentheses, similar to how we simplify fractions. So in this case, our A is 1, B is negative 8, and C is 12. We want to find 2 numbers that multiply to A times C, which is 12, but add to b, which is -8. Those two numbers end up being -6 and -2. And then we put those two numbers inside of our double axe, hippo butts. In this case, A is 1. So really it's 1. Oh, and the letter we're using is N. So it's going to be 1N. And the two numbers are -6 and -2. Then check to see if I can simplify the 1 and the 6. Can I divide both those by a number? No. 1 and -2? No. So then it stays as 1n, but we can just write n. And then 1n, but we can just write n. And that is the final answer. All right, try this example on your own, then come back to check your answer. Go ahead and pause the video now. And the answer is k minus 4, k plus 2. If you didn't get that, make sure you come and ask me questions next time in class. For this example here, notice that there is a GCF. There's a number I can divide 3, 6, and 189 by. I can divide all of those by 3. So we write our GCF out in front of parentheses and then show our dividing out of the GCF. 3v squared divided by 3 means there's a v squared left. 6v divided by 3 is 2v, and -189 divided by 3 is -63. And now we look only inside of the parentheses to get our new A, B, and C. It's a trinomial, so identify what your A, B, and C is. And now we do our number game. So what two numbers multiply to -63 but add to a +2? 9 and 7, and then it would need to be a -7. 9 and -7. And then we have our double axe, which in this case is a 1v and a 1v. We put them inside of our parentheses, but don't forget our GCF that we took out from the very beginning. And then we don't have to write the 1 out in front, so we can just have the 3 and then the v plus 9 and then the v minus 7 for the final answer. Our next example, A is 6, B is 1, C is -1. Notice, first of all, that there's no GCF. So that's why I went straight into identifying the A, B, and C. And we do our number game. So two numbers that multiply to A times C, 6 times -1 is -6, but adds to a +1. Those two numbers are a -2 and a +3. And we put that inside of our double axe, hippo butts. In this case, our A is 6, so now we have 6 and our letter is X. So this becomes 6x and 6x. Our two numbers are the -2 and the +3. And then we need to simplify. So is there a number that we can divide both 6 and 2 by? Yes, we can divide by 2. And that gives me 3x minus 1. Is there a number that I can divide both 6 and 3 by? Yes, that is a 3. And so that becomes 2x plus 1. So don't forget to simplify. For the next example, I want you to try this one on your own. Notice there are 1, 2, 3, 4 terms, so it's factor by grouping. Try on your own, come back to check your answer. Go ahead and pause the video now. And the answer is 2y minus 5 and x minus 1. If you didn't get that, make sure you come talk to me about it next time in class. These next two examples I want you to try on your own. For this example, make sure you check for both a number GCF and a variable GCF. And for this example, make sure you remember that if our leading coefficient is negative, then you need to factor out that -1. Go ahead and pause the video now and then come back to check both of these answers. The answer for the first example that you did is 4x times x minus 9. And then the answer for the last example that you did has a -1 out in front, but we don't have to write the 1, so we can just leave it as a negative. And then remember, you don't have to write the 1x and the 1x each time. You can just write it as x plus the 2 and then x minus the 3. All right, let's look at these last two examples. There is not a number that we can divide 2, 11, and 6 by, so there's no GCF. Identify your A, your B, and your C. Do your number game. So what two numbers multiply to 2 times -6? That's -12. But adds to -11. Those two numbers are a -12 and a +1. We put those two numbers into our double axe, Hippo butts. In this case, our A is 2, and the letter we are using is W. So we have 2W and 2W with the -12 and the +1. Now we need to simplify. What number can we divide both 2 and 12 by? That is a 2, and that gives us W minus 12 divided by 2 is 6. And then is there a number that we can divide 2 and 1 by? Well, other than 1, no. So then it stays as 2W plus 1. And for the last example, I want you to try that one on your own and then come back to check your work. Go ahead and pause the video now. And the answer is r minus 2 and 5r plus 6.